Integers are great for working with whole numbers, but there will often be times when you will want to work with numbers that have decimal places, such as when working with currency values. In C#, numbers with decimal places are stored as floating point numbers. The mathematics behind floating point numbers is beyond the scope of this course, but you'll learn how to create and work with them in this lesson. To begin, open the Shining Stone sample file from your Sample Files folder. And open the code behind file of buy.aspx. We are now going to add a floating point variable. To do this, add the following code to the page load event handler. Float test float equals 3.14159 f. Response.write test float. This code creates a new float variable called test float with a value of 3.14159 and writes it to the page. You need to end a float value with an f in order for it to be recognized as a float value. View the page in your browser and the number is displayed on the screen when the page loads. Close your browser now. Floating point values are only accurate within certain parameters. This can cause certain calculations to behave unexpectedly, giving you results that don't match up with other systems. There are three floating point variable types in C#: float, double, and decimal. Just like the integer types, the floating point variable types all have equivalent names in the .NET framework. The equivalent name of float is single, the equivalent name of double is double with a capital letter, and the equivalent name of decimal is decimal with a capital letter. The float variable type uses 32 bits of memory and is capable of handling very high values. It is the fastest floating point variable type and uses the least memory, but it is also the least accurate. The double variable type uses 64 bits of memory and can handle even higher values than float. It is also more accurate than float. Finally, the decimal variable type uses 128 bits of memory and is the most accurate floating point variable type. You should always use the decimal variable type when working with currency values. Use the float and double types when you need fast calculations and aren't worried about absolute accuracy. We are now going to see the accuracy problem in practice. To start with, either open the Windows calculator or another form of calculator and calculate the result of 3.14159 multiplied by 3.14159. As you can see, the correct result is 9.8695877281. Close the calculator and change the second line of code to response.write test float multiplied by 3.14159. View the page in your browser now, and as you can see, the result doesn't match what was returned by the calculator. This is because the float variable type is only accurate up to 7 digits. Close your web browser now. We are now going to fix the accuracy problem by switching from using a float variable to using a double variable. The double type is accurate up to at least 15 digits, so it should be capable of calculating the result correctly. Change your code to double test double equals 3.14159 response.write test double multiplied by 3.14159. You may recall that you had to put an F after the float value for it to be recognized as a float. You don't need to put any symbol after double values. Visual Studio assumes that any number with decimal places is a double by default. View the page in your browser, and this time the correct result is displayed. Close your browser, and we're now going to change the code to use a decimal variable instead of a double variable. Change the code to decimal test decimal equals 3.14159m response.write test decimal multiplied by 3.14159m. As you can see, you need to add an m to the end of a decimal number in much the same way as you add an f for float numbers. View the page in your browser, and again the correct result is displayed. Close your browser now, and remove all code from the page load event handler. You've now completed Lesson 5.5. Use floating point variables.